A-Level Paper 1, June 2018. Complete the Born-Haber cycle. So what have I got? I've got magnesium solid, staying as magnesium solid, half a mole of O2 gas going to O, so breaking the bonds, so enthalpy of bond dissociation or enthalpy of atomization. Magnesium solid going to magnesium gas, so enthalpy of atomization. Then what's going to happen next? Well, the next one that's endothermic is going to be the first ionization energy of magnesium to form Mg+, an electron, and the O gas stays the same, so you only change one thing at one time. So I'm changing the magnesium and the O is staying the same. The next one is another jump, Mg+ going to Mg2+, and an electron, so the second ionization energy of magnesium, and I've got one that comes down here. This is the first electron affinity of oxygen. So the O atom, the oxygen atom, gains an electron to form O-. There's still one electron left over, and this is the second electron affinity where it gains the second, where the oxygen atom gains the second electron to form O2-. And then we've got the lattice enthalpy here, where we've got gaseous ions forming 1 mole of a solid lattice, ionic lattice. I've put them into the diagram here so you can see what's happening. So I've got -602 will be the enthalpy of formation of magnesium oxide. So enthalpy of formation is forming the magnesium oxide from elements in their standard state. So magnesium is a solid metal in its standard state. Oxygen is a gas. Remember, standard state is how you'd find them in a laboratory. And then I've put oxygen going from oxygen O2 to half a mole of O2 into O, and I've cut, that's the bond dissociation enthalpy of oxygen, so that's a 496 here. And then we've got magnesium atomization, magnesium solid going to magnesium gas, so that's 150. So enthalpy of atomization of magnesium. Then we've got here, up to here was the first ionization energy of magnesium, which was a 736. We've got the second ionization energy of magnesium, a 1450. Then we've got the first electron affinity of oxygen, a -142, so it comes down. And then we've got a +844. The second electron affinity is endothermic. And then we've got the lattice enthalpy coming down here. So what am I going to do? If I start from here and come down here, this is the missing enthalpy change that I need, coming from magnesium, Mg2+ gaseous ions and O2- gaseous ions to form 1 mole of a solid ionic lattice, MgO. So I want it to come from here to here. So let's go from here to here is not +844, it's -844 because the arrow is going in the other direction. And then to go from here to there, the arrow is going in the other direction. It's a +142. Come down here, it's a -1450, a -736, a -150, a -496, and this one's going in the right direction, a -602. So when you add all of those up, it turns out as -3888 kilojoules per mole.